Hi there and welcome back. This is a multi-part video series on how to defeat the Ender Dragon in hardcore mode with Minecraft Math. This is episode 4. We're really working our way toward having all the resources we need to defeat the Ender Dragon. As you know by now, we're going to need a whole bunch of enchantments for our armor and our weapons, and the most surefire way to get these is via villager librarians. This is going to require a lot of books, so many books. You need 9 different enchantments, so that requires 9 lecterns, the job blocks needed to turn a villager into a librarian. A lectern is crafted from slabs of wood and a bookshelf. Each bookshelf requires 3 books, so 9 lecterns at 3 books each. That is at least 27 books just for the job blocks. Then there's the matter of the enchanted books. Here's what I prefer to have as I prepare to go into monster hunting mode. I put mending on pretty much everything. 4 pieces of armor, pickaxe, sword, and bow. Plus, I put mending on an additional golden helmet for going to the nether. That is a total of 8 books for mending alone. I need 5 copies of protection 4, 1 for each piece of armor plus a golden helmet. I'll need 2 copies of Thorns 3. I could do more, but Thorns 3 takes an awful lot of experience and it damages your armor as it hurts your enemies. I put it on my most durable pieces of armor, the chest plate and the leggings. So 2 more books here. I'll need Feather Falling 4 for my boots. I'll do Sharpness 5 for my sword, Efficiency 5 for my pickaxe, and Power 5 for my bow. Plus, Looting 3 for the sword and Fortune 3 for the pickaxe. That's an extra 5 books. So 27 books for the lecterns plus 21 more for the enchantments, 48 books total. Each one requires a piece of leather and 3 pieces of paper. You will need a lot of sugarcane and cows. Now, breeding cows isn't hard, but it does take persistence, and you need to hold off on slaughtering them until you have a sustainable population. Every time you breed cows, the population grows by the same multiplier, the same percentage, and so it's a perfect time to explore exponential functions while breeding your cows. You know exponential functions. Right here it says y equals k times a to the x power. K is your starting amount. A is the multiplier you use every time, and this multiplier is greater than 1 for exponential growth, and it's less than 1 for exponential decay. And x is your independent variable, in this case the number of days. As you know, you need to feed wheat to 2 cows in order to breed 1 baby calf. So if you have 2 cows, you can gain 1 more. If you have 10 cows, you can gain 5 more every time. The increase is 50% every time you breed the cows. If you start with 2 cows and you assume you breed cows once per day, and every time you gain half the number of cows, this is what your exponential function would be. You would have y equals 2, that's your starting amount, times 1.5, because you gain 50% every time, to the x power. I can create a graph and also a table of what this function would look like. We're going to click Add and add a table, and then our x's are our days. This is 2 times 1.5 to the x1 power. So I can start entering x values and it will automatically calculate the y values. Day 0, day 1, day 2, day 3, day 4, day 5, and so on. So as you can see, the graph starts off growing slowly, and then it takes on this unmistakable hockey stick shape as it grows. The population begins to grow really fast, especially as you really start to get up there in days. However, as I actually breed my cows, I realize this isn't how it's really going to play out. According to the Minecraft fandom wiki, the cows can be bred every 5 minutes, and baby cows take 20 minutes to grow up. This means the baby cows take about 2 days to grow up, since a Minecraft day is 10 minutes, and I'm not including sleeping time. I don't know how to model this as an exponential function just yet, but if I gather some data, I can look for a function that's a good fit. Does the cow population over time end up increasing by about 50% every day? Is it less? How much less? What do you predict? Let's collect some data and find out. I'll create a spreadsheet to gather some data. Let's make some baby cows. I was lucky enough to start with a herd of 4 cows that I lured into a corral, so my starting breeding population is 4 cows. On day 1, I feed my cows wheat. I'll have 2 babies, and I'll call these first generation babies. Day 2. The babies from yesterday aren't grown yet, but I'll feed the adult cows. I still have a breeding population of 4. Yesterday's first generation babies are now second generation babies, and I have 2 new first-generation babies. Grand total is 8 cows. Day 3. I'm going to use formulas as a pattern is emerging. The breeding population for the next day is the sum of the second-generation babies plus the breeding population from the day before. Now I have 6 adult cows. The second generation just brings down the first generation from the day before. And our first generation babies are what we get if we take half the breeding population and round down using the floor function. 3 new babies plus 2 older babies plus 6 breedable cows equals 11 total. Day 4. Now the 2 older babies from yesterday are grown. I have 8 breeding cows. The babies from yesterday are now second generation babies. I get 4 new babies. 3 second generation babies and my adult cows. 15 total. Day 5, the pattern continues. And now I have 20 cows. Day 6, continue the pattern. 27 cows total, which includes 15 adults, 7 new babies, and 5 second generation babies, and so on. I'm going to extend this pattern all the way until I have enough cows to guarantee me 48 pieces of leather for my books. When you slaughter a cow, they drop anywhere from 0 to 2 pieces of leather, so an average of 1 piece per cow with an unenchanted sword. 47 cows should do. I can tell that as I get to day 8, I finally hit 50 cows. Each day is 10 minutes long if you sleep at night. Fam, you have to consistently breed your cows for an hour and 20 minutes. You can do this. And it might be helpful to get your mind around how much wheat you need to feed all of these cows in order to get up to 50 cows total in your herd. Well, to figure out the number of wheat, we're just going to sum up the breeding population for every single day, assuming we give every cow a piece of wheat every day. And I ended up with 99 total pieces of wheat. It will really help if you find a village that has hay bales laying around, because if you have to farm this much wheat, it may take quite a bit of time. Now, out of sheer curiosity, let's drop this data into a regression model to see what exponential function actually fits best. I bet I don't actually get 1.5 to the x power, but I wonder if it'll be close. At desmos.com, I'll open the graphing calculator and drop a table in there. You just click plus and add table. I'll enter the data where x is the day and y is the total cow population. You can really see that quick exponential rise. It seems like at about day 6, dots get pretty far apart. The thing with an exponential graph is no matter how much you zoom, you always see that same pattern. To figure out the function that gives it the best fit, we're going to enter a regression function on the next line. It's easy. It's the same as writing a regular function, but instead of an equal sign, you're going to enter a tilde, which is a little swirl. I'll show you. I'll type y1, tilde instead of equals. My starting population of my cows is 4, times, and remember my exponential model is some number to the x power. So I'll say a, and then use shift 6 to do the little caret sign, x1 power. And then I get my regression function. So in this situation where the cows grow up right away, I would expect that a would be 1.5. But since my baby cows take 2 days to grow up, the growth rate isn't 50%. I can see from the way that a is in my best fit function that my cow population actually grows by about 37% per day, not 50%. But I can learn different things about this function if I enter it in slightly different ways. If I enter the exponential function this way instead, y1 tilde 4 times 1.5 to the dx1 power, d tells me how many times a day my cow population increases by 50%. My cow population increases by 50% 0.78 times a day, which is kind of a hard number to wrap your head around. But if I take the reciprocal, it tells me how many days I need in order for the population to increase by 50%, which is a little more useful to me. So instead of d, I'll do 1 over d. And now this number, 1.279, tells me how many days it takes for my cow population to increase by 50%. On average, it's about 1.28 days in between that growth. And many population biologists or wildlife biologists are interested in knowing how long it might take for a population to double. To figure that out, you enter the regression function slightly differently. y1 tilde, we're starting with the population of 4 times 2 to the 1 over d x1 power. So in this case, this d tells us about how many days it takes for the population to double. So if it takes 2 days for my cows to grow up and I can breed the cows once per day, then my cow population will double roughly every 2.186 days. And the long and short of it is, I'm telling you to breed those cows consistently every day for 8 or 9 days in a row, and by then you'll have enough to start slaughtering them and get all the books that you'll need, plus beef, plus XP. Cows are a very useful farm animal and just so cute, but don't get too attached, don't name them. Every farmer knows this. I usually make a smaller slaughtering pen attached to my main corral that I can gate off. It lets me cull a few of my herd without having to chase after the running cows. After you get looting 3 on your sword, you'll be amazed at how much leather and beef you gather this way. I hope you enjoyed learning about exponential functions and breeding animals. In the next episode, we'll explore probability and when you can expect to get all the enchantments you'll need from your villager librarians. You should look forward to it. It's a good episode. See you then, and thanks for watching.